We know that CPU is the core component of executing programs, but it can only process digital signals. When analog quantities need to be measured, controlled, or stored, special interfaces must be used to complete the conversion between them. This conversion is a D conversion and DA conversion. Let's learn about these two conversion devices separately. With the rapid development, and especially the rapid development and popularization of information technology in modern control, communication, detection, and other fields, to improve system performance indicators, in signal processing, digital computer technology is widely used. Due to the actual objects of the system are often analog quantities, such as temperature, pressure, sound, etc. For computers or digital instruments to recognize and process these signals, these analog signals must be converted into digital signals. The digital quantity output after computer analysis, need to be converted into corresponding analog signals to be accepted by the actuator. In this way, a circuit is needed that can serve as a bridge between analog signals and digital signals, analog to digital and digital to analog converters. In new energy vehicles, many signals are analog signals, such voltage signals, throttle pedal angle signals, and current signals are all analog signals. These signals need to be analyzed, stored, and controlled by computers. Computers cannot process analog signals. At this time, a conversion device is required to convert analog signals into digital signals. This conversion device is an AD converter. Next, let's take a look at how it works. Let's take a 4-bit AD converter as an example. As shown in the figure, the left input is an analog signal, and the right side is the digital signal. If the reference voltage is 4 volts, a 4-bit AD converter, it actually divides the 4-volt voltage into 16 parts. Each voltage is 4 volts. Divided by 16 equals 0.25 volts. That is to say, the voltage that the AD can distinguish is 0.25 volts. When the input voltage is X volts, the output value is X divided by 0.25. For example, when the input voltage is 25 volts, the output voltage is 25 divided by 0. 25 equals 10. 10 in binary is 1010. The output result is 1010. Corresponding to the AD converter pin, the output voltage is that D3 is high level, D2 is low level, D1 is high level, and 0 is low level. The 4 pins through high and low levels to send the binary data 1010 to the CPU. Completes the process of converting analog signals to digital signals. A 3 has 2 important performance indicators: conversion accuracy and conversion speed. The higher the number of bits of a D converter, the higher the accuracy of AD acquisition. Common AD converters have 8, 12, and 16 bits. The shorter the time it takes to collect, the faster the AD conversion speed is, the higher frequency electrical signal can be collected. Converter is a conversion device that converts digital signal into an analog signal, which is actually the reverse process of a deconversion. DA converters are required in many electronic devices. For example, when we listen to music, we need to use a DA converter to convert the digital signal of the music file into an analog signal, to drive headphones or speakers to play beautiful music. Next, let's take a look at how it works. Let's take a 4-bit DA as an example. As shown in the figure, the left input is a digital signal, and the right side is the analog signal. If the reference voltage is 4 volts, a 4 bits da converter, it actually divides the 4-volt voltage into 16 parts. Each part is 4 volts. Divided by 16 equals 0.25 volt. That is to say, this DA can output voltage is a multiple of 0.25 volts. When the input data is Y, the output voltage is Y multiplied by 0.25. For example, the data output by the computer is 10. The binary of 10 is 1010. Corresponds to the voltage of the input pin of the DA converter. The third is high level. The second is low level. The first is high level. DO is low level. The output voltage of the DA converter is 10 times 0.25 volts, which is 25 volts. It completes the process of converting digital quantity to analog quantity. The DA converter has two important performance indicators: conversion accuracy and conversion speed. Higher the number of bits of the DA converter, the higher the accuracy of the DA output. Common converters have 8, 12, and 16 bits. The shorter the time it takes to output a voltage, the faster the DA's conversion speed is, the higher frequency analog signal it can output. As we all know, chips are an important part of the field of electronic information. I hope that through this lesson, but not only understand chips, you can also lay a solid foundation. In the future, in the field of electronic technology, in our mother, you can contribute your own strength.